sometimes I do that, right? Just for you to have one extra piece of assessment in there. Okay, so the sum of, you know what, the first couple I'm just going to show you what they are because I think you all know how to do that. The number of sides would be 11, right? So it's 11 minus 2 times 180, which is 1620. The interior angle is really taking the 1620 and dividing it by 11. This, ladies and gentlemen, this is only true if it's a regular polygon, right? If it's not regular, we cannot assume that every interior angle will be the same. But the sum, this formula works for any polygon, right? This only works if it's a regular. Just putting it out there. The measure of each exterior angle was very similar to the quiz. The best way to do it is to just use the formula, right? 360 divided by n. Alternatively, we know that the exterior angle and the interior angle are supplementary, right? They add up to 180. So the other method would have been 180 minus the interior angle we just found. So that's the second way of doing it. So it's not the central angle. Some students were trying to, because the formula is the same, but you can't say that the central angle is another way of finding the exterior, right? If you go by the concept. Labeling, I mean, I think that was done fairly well. I just want to make sure C is not just putting the dot down. You actually have to make the cuts. One of the sides has to be involved of that polygon, right? And so that angle formed between the cuts is what gives you the central angle. It's just one. There will be, in this case, 11, right? If you were to go all around, but we just want one of them. Interior, exterior, there's another exterior just in case. So one and a half a mark for each of those. That one I will do, question 2, I will do from scratch. So the interior angle is this. Determine the number of sides, right? So this is a backwards question. We know that, right? The interior angle is equal to this formula, right? So the first step, I'm just going to do this, is multiplying both sides by n, which cancels out that. You're left with 172.5 n, and then you distribute here, so that's 180 n minus 360 degrees. And then I bring the 180 over, so it's 172.5 n minus 180 n, which is negative 360. This gives you negative 7.5 n is equal to negative 360. Then divide both by 7.5. N is equal to 48. So 48 sides. A lot of you use the other method, right? Your exterior angle is going to be 180 minus the 172.5, and that gives you 7.5 degrees, right? And then you use the formula for exterior angle, which is 360 over n. Put a 1 there, you cross, multiply, and divide. I would say I was very happy with the amount of steps you showed. So that was well done overall. Okay, next. Notice that one question may have on the test where you can only use each property once. Okay, so keep that in mind. So I want to emphasize the parallel lines here, right? And what could you solve for first? Maybe go for x first here. These are vertically opposite. I wonder if can I use that? If I use vertically opposite, I don't think I will need it anywhere else. So this is the first one that I solved. I appreciated you telling me which one you started with. So that's 32 degrees. And so vertically opposite angles are congruent. And then my next step was to, I don't know if you see it, but this transversal here, right, connects that parallel and that parallel line. So what are these two angles here? It's hard to see, but they're actually corresponding. They're both on the same side. So, but I already did that. Sorry, x is 32. Sorry, there you go. So y, which is the second angle I am finding, is 32 degrees also, and I use corresponding angles are congruent, right? So I went from here to here, and I went from there to there. Z I can find by using the sum of triangle, so that's my third angle. I'm going to go 180 minus 123. There's a very high chance you got it right, so don't erase just yet. 123 minus the 32 here, that is 25. So I use sum of triangles equal to 180. So if you're doing some actual calculations, that's good, but also make sure you write the property down. So I know that this is now 25. And M is way up here. M is right next to Y. So you can just use a straight angle right here. So it's 180 minus Y, which is 180 minus 32, which gives you 148. Straight angle is equal to 180. Can I just say that M is not corresponding, like these are not the same, right? I don't know, because this line right here that is intersected by this transversal is not parallel to that line, right? So you can't use that property. So that's that. This is the fourth. You know what? If you tell me which one you start with, that's to me the most important one. So you don't have to go 1, 2, 3, 4. Just tell me which one you start with. Then I can figure it out from there. Anybody do it a different way? Damon, you did it different way? A couple of you, because I actually, yeah. So this one here, this is my key. I went off script, right? So this is my key. I started with X. And then I went to this one here, Y. So I went with that. And I used, right, these two here are alternate interior, right? So that's what some of you did. That's fine, no problem. But you can only use each property once, okay? So it depends on how you start. It's all good as long as you don't mistakenly call something corresponding, right? Or alternate interior. It's just got to be the angle that you're actually referring to. All right, so next page. Anybody recognize this one? I think that was in the homework, 24 to 34 or somewhere. Work out the angle X. So they want this one here. Using assign letters to the angles you're finding along the way. Okay. Now, what kind of triangle is this? Equilateral. So I don't know. You can call that M, right? Angle M is equal to what? 60, right? Because you can say equilateral. So this is actually 60 here, 60 degrees. So what is a full circle? Like on this corner here, we know that this is 250. This part is 60. So we can find this one right here, which I'm going to call N. You can call it Y, whatever you want. Angle N is 360 minus 250 minus 60. So this is 300 here, right? Take away 250, so that's 50 degrees. This one right here is 50. Okay, and so now if this is 50, right, and it's across that equal side, then this will be 50 also. We can call this Z if you want. Angle Z, sorry, ZZ. Are we sleeping or what? Maybe 180, sorry, 50 degrees, right? Isosceles. And so angle X is going to be 180 minus 2 times 50. Angle X is going to be 80 degrees, right? Sum of triangles equal to 180. So X is equal to 80 degrees there. I would have been fine if you just put in numbers as you work towards it. I'm fine with it. Just make sure you indicate it on here, and then you will be okay. So, right, 360 degrees is the key here. Let's do another one. The whole, right, like this hole here kind of took some of the diagram away. I hope that wasn't too big of a deal. So this line here is parallel to this line because of those markings, right? So angle X, how would I find angle X here? Or is that a good one to start with? Probably not. I'm going to start with Y. That one is the easiest one here. So I'm going to start with Y. And Y is 60. Write it in there. Write it in here. Vertically opposite angles are congruent. Easy peasy, right? Z is also fairly simple. I can just use a straight angle here, right? So 180 minus 60, that's 120. And so that is a straight angle equal to 180. So that's 120. And the last one, X here. How would I do that one? That one is the hardest one. Yeah. Okay. So you're saying this is the same to this, right? All right. So we have that Z we already know is 120 here. So we know that if this is the transversal that connects the two parallel lines, yes, that's correct. This is alternate interior to that one. So this whole thing should be 120, right? So we can just go here and go 120 minus 38 to get that answer. So 82, right? Yeah, just checking. Alternate interior. There's another way of doing it. And so you could have also mentioned that this is going to get too busy, but we know that this whole thing and this whole thing, they should add up to 180, right? Consecutive interior. So if you went 180 minus 60 minus 38, you would get that little sliver here, which would still give you 82 degrees. One more. You remember this one, right? The original sphere has a volume of this. The new sphere has a volume of that. Determine a scale factor. Can I say something here? Zoom into. Can't do it. The camera can't do it. Doesn't pick it up. Maybe that's what's happening. Need to focus. Oh, there we go. This 3, right? That should give it away. That this is going to be k to the power of 3 is volume of new over volume of original. It's not just k. We're comparing volumes, right? So let's try this. K is going to be cube root of the 375 cubic feet over 732.42 cubic feet. The cubic feet luckily cancels out, and K gives you 0.80. So you would get 1 mark if these numbers are in the correct place, and another full mark if you actually take the cube root, right? So that gives you 2 marks there. I'll just give you the answers here. 32.19 is that, and this one is 7938. Something like this, you need to know how to work with scale factors. Okay, for the test, that'll be there. And I told you already the points of intersections. I will kind of ask you to find them using your calculator. So there's going to be something there that's going to test your knowledge of finding the points of intersections. No graphing, but finding the points of intersections. All right. At this point, I would like you to get back to that handout. Were you still writing it down? Sorry, Loris. There you go. You know that last handout I gave you yesterday? The tiling one? I gave you this handout on tiling, so have that out just in case. And then, yeah, go ahead. And then there's the other handout that starts, it looks like this at the front, have that out as well. And so have those, both of those out. And I want you to, for now, go to show if AB is parallel to CD. This is on page 19 of that stapled handout. Right? Page 19. Remember, it looks like this at the front. And then you go to page 19 on that one. It looks like this. 19. Right? Spanish, anybody? I'm sure it sounds familiar, even in French. How do you say 19 in French? 19. Okay, so that sounds very similar. So this is not really anything brand new, but I just wanted you to have a couple of examples here. Introduce variables as needed to show your work. So it's asking, right? Is this happening, right? Is this line indeed parallel to that line? They certainly look like it, but we don't know for sure. So let's focus. Let's make sure these are highlighted. And you notice that there is a transversal on both sides, right? Both sides, like there's a polygon involved, and so this is my what we call a transversal. This is my transversal, right? Don't pick both sides, just pick one of the transversals, right? And if you don't know what to do in this case, try to figure out information you can calculate. Like this angle right here, what is this angle here? What would we call it? Don't look at the parallel lines, just look at that pentagon. That would be the interior angle of a pentagon, correct? So let's call that x. So let's figure that out first. Angle x is number of sides of this particular polygon is 5, right? So this would be 5 minus 2 times 180 divided by 5. If you've done a bunch of these, you know that the interior angle of a pentagon is 108 degrees. It's 108. So you can actually write that down here. So this is my first step. I just went, right? So we can say step 1, right? We figured out the interior angle of the pentagon, right? Interior angle of pentagon. We did that first. Let's involve you here a little bit. What if we are looking at these parallel lines? What would these two angles be right here? What would we call these two? Consecutive interior. If you didn't have a mask, you'd be whispering it, and I'd be like, yep, that's exactly what it is, right? But yes, I'm hearing it. And so yes, consecutive interior. What do they have to add up to? What would we want them to add up to? 180 if possible. Then we could say, hey, these lines are parallel. So we somehow need to figure out this one here. Let's put a letter there. How could we find out y, knowing everything we know so far already? How is it possible to figure out that angle right there? Is there perhaps a way to figure out this one here? What do we have up here? An isosceles triangle, right? And we know this is 108. We just figured that out. So I'm going to make this my step 2. Angle Z is going to be equal to 180 minus 108 divided by 2. Does this ring a bell? This is inscribed polygons, right? Like these dashed lines are creating inscribed polygons, which you should be familiar with. So I'm taking this triangle here, 108, right? Take that away from 180, split that in 2, right? That gives you 36. Okay, so we're getting warmer. We're getting there. Step 3. And you know what? As long as you don't have to do like step 1, you don't have to show me that, but somehow organize your work here, right? Step 3, I'm going to figure out what y is. How would I figure out y? I know this interior angle, if I don't look at the dashed line, is 108 degrees, not 180. A lot of you went 180 minus on the quiz, right? Whatever the interior angle is, it could be 140, it could be 135. In this case, it's 108 there, if you're looking at the pentagon. And I'm going to subtract angle Z from it. So it's 108 minus 36. Angle Y, 8 minus 6 is 2. 10 minus 3 is 7. So I have that, right? So I can now say that this is 72. And I'm going to make these stand out there. And then use conclusion. Okay. AB is parallel to CD, right? Since consecutive interior angles add up to 180 degrees. And you're good. I would stay away from alternate interior, alternate exterior. I would not use them because you have to do more work outside the shape. I would just leave it like that. There's one thing you could have done is if this is 108, what's this outside here? 72, right? So yes, if you show that, you can also say alternated interior angles are also congruent, right? Are congruent, therefore that would have been another way to kind of strengthen your case. So this is what I'm saying. Try to almost use your inscribed shape knowledge to fill in what you can, and then just see, oh, wait a minute, yeah, I recognize that these two should be adding up to 180. So then you're good to go. Okay. All right. Thinking I want to give you a test checklist, and then maybe do one more here for you too. So let's do the test checklist first. Does this handout have a blank back, or no? This is the back for you, right? In that case, I would say just grab a piece of loose leaf. And we'll call this chapter 2. I will say this, use these ones to show if lines are parallel, okay? And obviously corresponding, like the first three are need to be congruent. The last one adds up to 180, okay? So gotta make sure you make that distinction. Determine unknown angles using right vertically opposite, right, straight angle, sum of triangles equal to 180, sum of four-sided shape is equal to 360. We haven't used that a whole lot, but some of you did use it, okay? And remember, these ones are always true. Those are always true. You can use them regardless, right? Regardless whether or not lines are parallel. polygons. Know how to calculate this is just an acronym, right? To remember, right? The sum, the interior, the central, the exterior. Did we do number of diagonals? I gave you the formula, but you don't have to worry about you don't have to worry about that one in particular. So know how to do that. So formulas should be on your study sheet, right? Inscribed. Polys, right? You need to know your isosceles triangle, right? It's 180. Trapezoid, 360, and pentagon, which is 540. And there are these formulas that, right, you keep on subtracting from and dividing it by 2 to get the 2 base angles. Be able to show that lines are parallel inside polygon and then going outside of that, tessellations. Can you tile a floor with regular shapes? Check if interior angles, right, amount to 360. Chapter 8, right, scale factors. Remember 1D, 2D, 3D, like know the difference, right? Whether or not you need to square root, cube root, all of that. Chapter 6, finding POIs, right? Solve for X types of question. And what I mean by that is if you have, you know, something like this, and this is 2x, and this is x minus 2 or something like that, right? Like there, we did a bunch of questions like that where you have to figure out the missing variable. Knowing that there's something true about them, they may add up to 180, they may be congruent. If it's a triangle, then all of them add up to 180. If they're inside a pentagon, they would all add up to 540. Solving for n, right? Number of sides. of poly. And in that booklet, there's a test at the end, like a chapter test. Page 36 to 39. Chapter test, page 36 to 39. That one is a very good one. And page 22 to 23, which has inscribed shapes, right? So if you want to practice a little bit more of your inscribed skill, then that's where you get it. Any questions? Comments, concern? Call 1-800. I have to come up with a number. I think this is everything that I can possibly